live here. Give me a minute for the Twitch delay. This slide deck has more slides than I normally have, but there's a decent reason for it. All right, I see myself here on Twitch. Okay, so today is August 29th, 2024. We are in week 3 of, that's not true. This is class 3, week 2. All right, we are in week 2 of CSE466 here at ASU. And the thing that we're kind of talking about is program security. So my slide decks begin with memes. These are all your memes. Some of them may have come from 365. The idea being here, hopefully your memes bring up things that are worth discussing. All right. So I kind of gave this mean, frank discussion here at the beginning, first class, second class, so everyone got the same spiel. The prereqs that I stated were not a lie. Hopefully we've taken a look at the material, given it a shot. The expectations are real. You'll notice that I'm not teaching you x86 assembly. I don't intend on it. A consequence of that, maybe you could have considered reviewing 365 and kind of what the material that was taught there over the summer. If you didn't, you might be struggling a bit right now. It's perfectly natural. You had a summer off. Good meme. I dig it. This is a very common, kind of failure point for students in general, but in particular in this class. And I do it as well. Like, it's just when you're working on these type of things, you don't necessarily know when to walk away from it and go and find that information. And so oftentimes we'll find ourselves kind of running against a brick wall repeatedly. Again, the course reality is kind of hitting here. If you thought you were going to have a great partying semester, probably not. This one, I have mixed feelings on this because I'm not sure where they're going here with asking for help on old challenges. These are challenges. This module is entirely challenges that have been around. So maybe that's what they mean when they say old challenges. You're welcome to ask for help. It's encouraged to ask for help. Please ask for help. Kind of qualifying that, yes, there are pre-recorded lecture videos. I am here. There is the Discord. And I try and be pretty responsive on the Discord. If anyone has been on there, hopefully you've seen some of the responses that I give. I try and put in quite a bit of effort to answer your questions as detailed as I can. However, there are pre-recorded lecture videos for a reason. And there is a limit to how much I will repeat myself in the Discord. I'll just link to a lecture video timestamp, or I'll link to a previous method. It's not an issue right now. I just want to make sure with it being posted that everyone is kind of aware that there is a line there at some point. A few of us decided to dunk on me, which is totally fair game. You got the extra credit. I had the slide with the typo. This is the cooler name. It's totally fair. We also got me here because I do use SSH in the terminal, but it's not because I am just an amazing lead individual. It turns out that is just my preferred way of working. And if you like VS Code, I am probably more useless than you are in a terminal if you prefer VS Code. Right? So this isn't a superiority thing. This is just the facts. I'm sorry?
Dave, you roasted all of us in here at the same time.
Yeah, you can hit me back, right? I think that's fair as a class, right? As long as it goes both ways, we can have fun as we move through it. This one here, that one hurt a little bit, guys. All right, but I'll give it to you. So I'm here Tuesdays and Thursdays where I'm lecturing for the class. Attendance is not mandatory. That's your call, but I do enjoy it. Monday, Wednesday, Friday is the pwn.college Hour of Power, which has been going on this week. That's where we have some TAs, some knowledgeable people there that are not me, although I will drop in and did drop in yesterday at the tail end to help anyone who is still sticking it out. And if that's your preference, that's totally fine. It's not mandatory. Get what you're after. Is that a hand back there?
Yep. I noticed you mentioned that there was I think a meme like 2 slides ago that mentioned brushing up on some 365 material beforehand.
Yes.
I was wondering, do you have any tips on what prerequisite material particularly to study for this module?
So I had a slide deck that mentioned kind of what the prereq expectations were. And that's fair. Like, I didn't link directly to material. But if we go to the this course, which is CSE466 Fall 2024, right here at the top, and this has been here since I think day one of the course, might be day two. This is a link to the whole course. These are the links to the 2 modules that are the absolute most relevant to what we are doing. And I know I stated that at least one of the 2 prior lectures, if not both. So I did link that and make that available. If you want to take a look at it, that's great. It may be a better starting point for you. However, the clock is ticking because we do have an active assignment. All right, so we did some Robert lore, and then there were actually a few memes that were quasi-helpful, if you know what they were referring to. So this one here is talking about memory corruption, which is kind of the second half of the assignment that's out. And okay, you could be super strategic with things and use GDB and use some of these fancy tools. You uniquely identify the exact memory location that you want to corrupt, or you can just be like, you know what, I got this, and you just send a whole bunch of A's. Just send it and see what happens, right? It's totally valid. However, this approach will not work in all cases, right? So at some point you will run into something where you can't just send a whole bunch of bytes, and you do have to use some of the more advanced tooling to reason about what is going on inside of the challenge. A few more kind of useful memes here. This one was right before class, which was a good hit. It says here, shell coding, sys open, sys read, then sys write. So a very common thing you may want to do with shell code is called open, read, write. Turns out that's 3 sys calls. Right? This guy's pretty sad because he has to write a lot of assembly and have some long shell code. We're doing 3 sys calls. There is also this syscall that you may or may not have heard called chmod, which allows you to change the permissions of a file. Chmod takes 1 argument. It is 1 syscall. If you were to call chmod and change the permissions of a file so that you can access it, then you could cat it afterwards. And it's way less bytes, way less work than just trying to open it, read it, and write it. Something worth considering. This other one here. I'm going to circle back to where this is going. This is from 365. They're doing like some intro to Linux stuff at the terminal. But what it says there is ln-s, my file, our file. They're creating a symbolic link to my file named our file. And then they're doing the inverse. If you're not familiar with the symbolic link, I plan on touching on that today once I get to the demos. The TLDR is you can think of them as pointers on your file system. It is a file that points to another file. So in this case, we have 2 files that are pointing to each other, which is kind of useless, but it does bring up the concept of a symbolic link, which is something that you can use to your advantage in this module. The one over here on the bottom right was earlier, and this is, I think, from what I've seen, where everyone is, for the most part, at, right? There's a large number of students that immediately kind of brick-walled here on level 4, which is awesome. Level 4, if you haven't taken a look at it, is a challenge that says, send me your shellcode, do not use any H bytes. And so this H is floating here, kind of haunting your shellcode, right? Which I kind of dig with. Now, there's one more meme, and this happened late last night and kind of changed up my evening plans. This meme here says, cat flag suddenly starts working. And then we realize, wait a minute, cat flag suddenly starts working. Okay? You'll notice that the title of this slide is We Messed Up. So, does that say 29? What's today? All right, so I got the date right. So yesterday, for a period of about 3 hours, every single user on pwn.college could have exploited the platform and obtained the flag via cat flag in every single challenge on the site.
That blows. Wait, so what happened to the students who used that?
So this was brought to my attention by someone that is in CSE466. Their handle here is Attical. Does Attical want to identify themselves? It's up to them. Okay, so we have a hand. That's Attical over there. They brought the issue to my attention. I took a look at it, and it is squared away. As far as what happened to the students that used it, our general stance on pwn.college is the flag is the flag is the flag.
Oh, no way.
Now, with that said, there is kind of a ethical deal there, right? Like, it's probably not good to do that. And so if it was an insane abuse case, all right, we'd go down and chase it. But I'm not going to go out of my way to see what people did. Things will just be what they are, and we'll leave it there. Now, one other thing that is worth kind of mentioning here, if I take a look at the syllabus, I didn't mention it on the slides, but hopefully people do, in fact, read the syllabus, is we offer something called Bug Bounty Extra Credit. And I didn't mention it on the slides because it has been, I'm not logged in. It has been so rare, it hasn't happened in years. So I was the first one, we got problems.
Look at that.
That's no.
Yeah.
Long passwords are your friend. Okay, so I'll take a look here at the syllabus. And down here near the bottom, when we're talking about extra credit, it says more extra credit bug bounty program. It turns out if you find a vulnerability in the infrastructure, this isn't like, I goofed something in a challenge that I added, right? But in the actual infrastructure that runs the site, and you responsibly report the vulnerability or issue, you can get, depending on our assessment of how impactful it is, anywhere from 1 to 25% of the course in extra credit. This was a vulnerability that, as I said, everyone could have possibly obtained at the flag in every challenge. That's a pretty high vulnerability threshold. It's safe to say that Atacol is going to get some extra credit, and good for them. So you could abuse it, or you could just cash in right away and walk away if you happen to find something like that, right? Which I think is a fair deal, right? Because it turns out like doing security, even for those that know security, is hard, right? It's actually quite hard to get everything right. And so we're going to take a look. This is the commit that happened last night that caused, it's a little bit small, so the next slide here will make it a little bit bigger. It's actually 2 lines.
Wait.
This is the commit that caused this to be possible. So they don't have any idea what could have been the vulnerable path here. For those in the back, I'm going to tell you right now, it's this first line that is an issue. This runs every time a challenge instance starts because 365 was chmodding their home directory and locking themselves out and doing goofy things. I got a hand. What do we got?
But isn't that entire thing one line with the plus and everything?
No, it is in fact 2 different lines. The plus has special syntax for fine.
With the fact that the change owner, the ch own thing.
So what it says here is find home hacker. So we're searching every file in the hackers directory. Anything that is not owned by UID 1000 and GID 1000, which is the hacker user, we're going to exec chown, which will change the owner to UID 1000. So anything that is in the challenge or the home directory will get changed to be owned by the hacker user if it is not owned by the hacker user now.
So that gives the flag file user ownership because that file is originally owned by root, I believe.
The flag file is located at root, not in home hacker. So no.
So symbolic links.
Okay, somebody says symbolic links. That's a good start. That is part of it. Well, there's one other component to this. What do I have to do with a symbolic link to make this work?
Link a file in our home directory to the root flag.
Okay, but if I do that, it's going to have UID 1000. So how do I bypass that? Because it would skip it. If I just do it, I log in, I hit run, and then I create a symlink, it's going to be owned by hacker. You are the hacker user. How do I solve that?
In practice mode, you have sudo.
There we go. So in practice mode, we allow you to use sudo or run as root. That way you can use advanced debugging tools, right? You can play around. So you can sudo ln-s/flag and then put that file in your home directory. It would pass this check, and the chown will flow through the symlink and allow and change the flag to be owned by hacker every time you start up every challenge.
Are we allowed to do that regularly? Or does this commit not?
You're allowed to. Obviously, if I'm telling you about it, I fixed it. Okay?
Why did you just chown recursive?
So I didn't include this wasn't my code for the record, but I'm not trying to blame. Like I've done giant foo bars as well. The fix was to do exactly that, right? So for whatever reason, the person who made this commit was like, hey, yeah, this makes sense to do that. The fix was, yeah, let's not use find to specifically call on a symlink because that's what flows through if I use chown or chown here, and I just pass it a -r, it will recursively flow from home hacker on down and behave as one would expect.
You said the symlink would be root when you start a challenge, but what if you just get the slash flag that isn't the root? This code should not give you access to that flag, right?
So the issue is that if I create a root-owned symlink that is in home hacker, then it passes this check, and then chown changes it.
Yeah, but I still need to do cat slash flag.
Yes, because the issue is not that we're choning the symlink. By choning the symlink, we're actually choning the flag. It flows through. That's how symlinks work. Good question. We haven't in-depth covered symlinks, nor do I plan on it. But they're definitely something that we can use, and we'll touch on a little bit here. All right, logistics. I said repetitively, start early. This is hard. I took a quick look before I walked over here. There are currently 27 students who have not linked their account to pwn.college. So as far as I'm concerned, you're not a student. I hope that you intend on dropping. The drop deadline, I believe, is 9/4. Don't hold me to that. But it's early next week. I think it's Tuesday, Monday or Tuesday of next week. So you do have the weekend to sort that out, but that isn't a good sign. All right. 40 students have managed to link their account, but they haven't solved a single challenge. That could be because it's too hard. That could be because you're just busy and you don't want to start it on the weekend. Right? I don't manage your time. I just wanted to point out this number so that you're kind of aware of where you're at. I'm aware that you haven't started. So if we reach this deadline and there's a whole bunch of people that decided to start last minute and they're like, hey, I didn't have time, I told you to start early. Okay, I have claimed I'm going to upload some videos for you. It turns out during the day, it's very easy to DOS me, right? Especially when I help people on the Discord and I do other things than run this course. Typically, the time that I have to record videos and do dedicated focused tasks is really late at night. I uploaded the first video, which is immediately relevant to the first half of this challenge material. It's an applied kind of shellcoding tips and tricks video, which I'm going to do some of the same things that are on there, but I'm not going to spend a lot of time explaining what I'm doing. Check that out. It's about 40 minutes long. Skip to whatever part you want. It is applied. I'm not explaining what shellcode is. I'm not explaining the layout of process memory. I'm showing you different ways that you can generate shellcode, debug your shellcode, reason about what's going on. Hopefully that is a good reference for you. I have two more, again, application-focused videos I plan on releasing hopefully later tonight. One of them, you see the slide deck, which is going to be kind of quick tips for dealing with memory corruption, calculating offsets, using PDB, etc. A question that kind of came up, we weren't sure, was when will I have office hours? Last week, Thursday, I said, what do you think? You wanted something early. I said, I'll shoot for Friday at noon. I asked Tuesday's class. They were kind of wishy-washy, didn't care. Friday at noon. We're going to go with Friday at noon. I haven't submitted the request yet. That's on me. So I don't have a room to direct you to, but Friday at noon tomorrow, I will be streaming on Twitch for an hour to 2 hours, depending upon how much questions and engagement we have, and we will go from there. All right? Yes, question.
Just a question on the book. Can you tell us what time period that was? Because I want to make sure I actually legitimately solve the challenges, not just.
So did you create a? I can. So the dojo itself is all of the code that runs it is open source.
I think I can actually say the exact elements.
So you can look at our commit history here, and it's going to be from this to this, which may or may not show the exact times. And 20 hours ago to 17 hours ago. So do some math or check out the GitHub. The timestamp's there, I'm sure, if you want to pull it. What's that?
It was around 7 or 8ish yesterday.
Okay. But if you got it, you got it. I appreciate it. That hey, you want to actually learn the material. That is the point.
Try running your script again.
That's very, very true. Yeah. Okay. So I will hold office hours for a couple hours tomorrow. Unfortunately, it's going to just be streamed. Okay. So my plan for the remainder of our time, which we've got about 45 minutes, I'm going to try and bang through the slides in 15 minutes and then have a full hour for whatever it is we're demoing and kind of talking about. This is my plan. Right before class, somebody hit me with a question, hey, why does your GDB look fancy? Right? I'm using GDB and my GDB doesn't look like yours. That's really easy to answer. So I'm going to show you a couple of GDB plugins. One is called Jeff, the other is called pwn.college. You can use whichever you like, and how to set that up on the dojo so you can have the exact same thing that I'm showing you. This next thing I want to show is just generating some shellcode, how to kind of rapidly iterate, and how to think about some of these challenges. Because the earlier shellcoding challenges here ask you to shellcode under constraints. They say, generate some shellcode, here's some rule that you must follow, and then if you didn't follow it, it breaks. And depending upon what process you are using to generate your shellcode, it may take 3 minutes, 5 minutes for you to make a change and then find the answer to, does this solve my problem? Or if you're quick and smart about it, you can change your assembly, hit enter, and in 5-10 seconds, know whether or not this was a good change. And so I'm going to try and show you that, and we'll kind of iterate through some shellcode permutations. I'm going to look at some optimization strategies, some things that we can do that will improve our shellcode other than just writing the shellcode. And then if I have time, I don't expect to, we'll run through some practical GDB usage because this is relevant, and from what I've seen, people are not as familiar with GDB as I would like. So this is my plan. Does anyone have anything in particular they want me to touch on? Yes?
Okay, so this might have been covered in your video, but I wanted to ask, when working with the shellcode, how can I view what the shellcode is doing to my memory when I'm using GDB? And my memory is the stack actually.
Okay. So the question for Twitch, I can definitely demo that when we're up here. I just make sure to include it. The question was, how do I debug my shellcode in memory to kind of analyze what is it doing to memory? Like in particular, what is happening on the stack when my shellcode is executing? It's a good thing. I can definitely include it. Yes.
On the topic of optimization strategies, besides just trying to use different instructions, how might you determine
that is
to make the bytes unique?
That is literally not uniqueness, but this kind of bullet point is going to be everything that you can do other than changing your shellcode. Okay. All right, that's why it's a separate bullet point. All right, if nobody has anything else, I'm going to just kind of hop right to it. So first off, I should probably let me know, is this big enough for people? And let me double check Twitch.
Yeah, we're good over here.
So my phone, I apologize for Twitch users. I do not see the chat logs.
Apparently your phone's flashlight might be on.
It is.
Yeah, it is.
I don't think that's breaking the Twitch chat. That'd be pretty cool if it was.
Another vulnerability.
Thank you. Thank you. All right. So I'm going to go here, and it doesn't matter what challenge I start because what I'm going to use as an example here is not going to be the actual challenge binary. I prepped a couple generic binaries that essentially do something very similar. And we'll be messing around with those because I can show you the source of that so you have a quick idea of what's going on. Assuming the dojo is not on fire. That would be my luck. All right. I didn't include the memes that were kind of dunking on the dojo catching fire, but they're totally valid as well. I don't know if... All right. I'm going to try... There's all your memes. Can I blame Safari? Yes, we just blame Safari. I need to start using Firefox. I use this switching modes between like streaming and not streaming. And for whatever reason, Safari has this feature, but it doesn't work very well.
Firefox probably has a plugin.
So in previous iterations, I've used Firefox, and so I'll probably just switch back to that. One of the things that you'll notice right away here as I start the challenge is I didn't click on Start. I clicked on Practice. All right. The reason that you click on Practice, as was mentioned earlier, is you get the ability to run sudo. You can run as root. No, you can't get the real flag, but it's extremely useful for debugging your shellcode or debugging anything that you're going to do in this course. So unless you look at this and you're like, I instantly know how to solve this, my recommendation is do not click Start, because you're going to write something, you're going to work on it, you're going to run into a problem, and you're going to be like, oh, I need to be root to analyze this. Start everything in practice mode until you have it figured out. Okay, so now let's see if the internet works. It does. Okay. So I have here a very simple binary. This is kind of the boilerplate textbook example of something that's called like a shellcode runner. You don't necessarily need to know what it does, but I'll run through it real quick because this is the binary that I'm going to be using as a toy example. And this was very much so how the challenges work as well. They just have a lot more output that gets displayed on your screen. So I have a character buffer here that's 256 bytes in size. You'll note that it's inside of main, so this is a local variable. It will be on the stack. I then call read on 0. 0 is standard in, so I'm going to read from standard in. Those bytes are going to go to this buffer, which I described up there. I'm going to read 256 bytes. There's no buffer overflow here. This is just getting some bytes onto the stack. The C syntax for function pointers is a bit of a mess, but what I'm doing there is I'm declaring a function pointer called func. It points to a void function. I am then casting buffer as a void function and then setting func to point to this buffer, this region of memory, to treat it as if it were a function. And then I am calling it. You don't have to worry about all of these magic parentheses. You will never have to write this in this class. All right. But I feel it's worth at least explaining so that you have an idea of what we're doing. So I have, hopefully this is it, some challenge. I can enter, and we get illegal instruction. Why? Because what I just typed there is not valid shellcode. All right. Now, I'm going to immediately kind of default here to using Python and pwn tools. If you are like, hey, I'm doing something else, and I like that, but I'm kind of Python curious, check out that 40-minute video that I released late last night or early this morning, depending on how you look at it. It'll start on the most basic things you can do to generate shellcode and get you up to using Python. If you want to be effective in this course, you're going to be writing a lot of Python. You're going to be using pwn tools. It's going to be the fastest way to succeed in the course. Yes?
So using the raw shellcode isn't the best option right now?
So you can do that right now.
Okay.
If you check out the video that I uploaded, I start off with, well, we could run AS, the assembler, to create an object file. We could then call LD to link it so that we get an ELF. I could then call object copy and pull out that raw shellcode.
And I guess my only question is, because I'm in the video, it said that it was for us to use that because it was easier to debug over pwn tools.
It is not.
It is not. Okay.
I don't know. Did I say that?
No.
Okay. So in my very strong opinion, the answer is it is not. It is more straightforward in understanding how an ELF is created. Where does shellcode come from? How do you do this?
Okay.
However, there's a lot of steps involved there. There's a lot of things you have to type. There's a lot of things you can get wrong. It takes a lot of time, right? It's definitely worth doing once or twice so that you understand the lower level actions that are occurring. But once you are like, hey, I understand these commands or the commands and what they do, at least at a high level, I'd stop doing that because it's a waste of your time.
Okay.
All right. Now, I'm going to use IPython 3, which is an interactive Python interpreter. You do not need to use IPython 3. Anything that I write in this interpreter, I would recommend you write in a Python file. Write it to a disk, name it do.py is usually what I name my files. But it's easier for me to demo using an interactive interpreter. The reason that I recommend you store stuff in a file is in the event that something breaks, the challenge instance goes away, you have it written to disk. If you're working in an interpreter like this, you have to worry about state from commands you've ran earlier. If it quits, you may lose what you were working on. You come back later, it's not there. If you already know how to use and kind of work in an interactive Python session, go for it, but it's not my suggestion. Okay. Question, yes.
So two things. One, I recall at the beginning of the class, I think you mentioned that we were going to be doing a lot of C in this class. Is that true, or will we
There will be some C writing. For instance, all of the binaries that we kind of deal with, I'm pretty sure, don't hold me to it, will be written in C. So the programs and challenges that we're debugging and reasoning about are binaries that were written in C. There's binaries actually look quite different depending upon the language that is used to compile it. So for instance, a C++ binary would look very different than something written in C. You need to understand the C programming language because when we get to the next topic, which is reverse engineering, one of the tools we're going to use is something that's called a decompiler. A decompiler lifts assembly up to a C-like syntax. And so that means if you don't know how C works, you're going to have a bad time looking at this C that isn't C. But as far as your actual exploits, the vast majority of it will be in Python. I know the microarchitecture module will be in pure C. That's just because of the nature of how it was. But you can use the language of your choice. If you decide you want to do it in Bash, I know there's someone who's been going through pwn.college for several years now, and they are committed to just solving everything in Bash. Which is crazy to me. I love Bash, but not that much. You are free to use the tool of your choice. This is my recommendation. Feel free to ignore it at your own peril. I'm going to start with some boilerplate here. I'm going to say from pwn import star. I'm importing pwn tools into the global namespace. If you're a programmer, global imports are bad. If you're hacking, this is great. Okay, the next thing I'm going to do that is some boilerplate is I'm going to say context arch equals AMD64. Did I mistype? No. Okay. So AMD64, there's a couple other things that you can set here as well. By default, pwn.tools is going to assume that you are working with 32-bit assembly or 32-bit binaries. And that means that if I'm working with 64-bit stuff, it's going to yell at us because it doesn't know what RAX is, RDI, etc. So these 64-bit registers don't exist. So we need to inform it that we're dealing with a 64-bit context. Yes?
What about like when we're setting context like arch or like terminal, like where can I go to like see what possible like strings I can put for that?
Okay, the question is, so I have this like magic arch thing. How do I know what I can put there? So in an interpreter, you saw what I just did, is I have something and I don't know what it is. I can append a question mark to the end of it, and that is going to bring up some help text. That is assuming that the developer of whatever it is I'm expecting wrote some documentation for it that Python can surface to me. If I am still confused, I can double question mark, and that is going to show me the source or the implementation details if things are working. And lastly, which is probably the default answer here, is look at the actual documentation. So pwn.tools is a pretty big project. It has been around for a long time. We can, for instance, go to the pwn.tools docs, search for context, and we're going to find it somewhere here. Pwnlib context, setting runtime variables. There's actually a ton of different things that you can set. I'm only going to talk about the ones that are immediately relevant to you. Feel free to read and do whatever you'd like. Yes?
AMD 64 over x86?
Yes, so I believe you can use x86 as a string, x80, so i386 is the 32-bit default here. I think you can specify x86 64, does the same thing. I will always use AMD 64.
Okay.
In the back.
Yeah, I do have one question. If you scroll up to the very first one that you did, the very first one.
This is the first thing that I typed. I'm not scrolling up, but I just went through the history.
How do you end up with them not creating a separate input box?
Okay, so the question was, if I can type, oh no, bad things have happened on the internet. All right, I start off with this one line. How am I getting this kind of multi-line setup? In a default configuration of IPython? The answer is Control O.
Control.
Every time I hit Control O, it's going to add a line for me.
Thank you.
That is configurable if you like Vim keys. That's just not what I have going on here. Right now, this is the default. So, back to where we were. From pwn, import star. We set our context to let, our architecture in the context to let pwn.tools know that I'm working with 64-bit architecture. Now, the first thing that is immediately relevant here, the dojo is screaming, is this ASM function. So some people mentioned a little bit ago, hey, I'm using kind of this manual process on the terminal to assemble my object file and then link it and then yank out and yoink my shellcode. And is using raw shellcode the right way? The answer is using raw shellcode is the right way. There's just smarter ways of getting raw shellcode. So if I, in this little box here, type move RAX 1337, and then I print my shellcode, what I get here is a byte string. This is the bytes that are the shellcode for this instruction. That was super fast instead of having to run multiple commands. Even if you write a shell script, I'm pretty sure this is faster. Question?
Why not just do like a hex dump of it?
So you could do a hex dump of a file, but again, now I have to call hex dump. If you watch the video that I uploaded earlier this morning, I totally get that you might not have. I actually do that, where I dump it to a file and I use hex dump to look at the hexadecimal values. You can do that. I'm trying to show the optimal fastest path for you to get cruising. All right. There are other ways to do things. They're all valid. Use what makes sense for you. But if you want to spend time thinking about bytes, this is the fastest way to do it. If you want to spend time typing things in the terminal and doing hex dump, you can do that. I don't know that that's the most efficient use of time. So that's a byte string. That's great, but this is kind of ugly and it doesn't tell me a lot, right? And just to kind of show, I could move RDI and we'll give it beef. Beef. Right, now we got something longer. And the problem now is I don't know what bytes correspond to what instruction, right? You get this thing that says, hey man, don't have any H bytes. And okay, there's an H here, there's an H over there. Why do I have these H's, right? And you may be like, okay, I don't know what to change. You just start changing stuff. That's a waste of time. We can do better. pwn.tools exposes a function called disasm, a shorthand for disassemble. If we print this disassemble, what we see here now is a pretty representation of our shellcode bytes. And we see these are the bytes that correspond to this instruction. These are the bytes that correspond to this instruction. For those that are unaware, I'm just going to save you a little bit of headache. 48 is an H byte. We chose H not because we don't like the letter H, but because it has a semantic meaning. It turns out when they changed x86 from being 32-bit to 64-bit, one of the implementation details is a lot of 64-bit instructions are equivalent to a 32-bit instruction. They just throw this 48 in front of it. And so if I were, knowing that, if I were to change both of these from RAX and RDI to EAX, EDI, look, it's gone. Now, let's say I didn't know that. Well, I can still pretty quickly here be like, what about push, pop? Well, let's push a number. Let's push 61. Let's pop into RAX. All right, cool. Was that pretty quick for me to like change what I'm working on and then immediately get results that are nice and easy to parse? The answer is yes. Question.
Is push a 64-bit operation?
The question is push a 64-bit operation? That is a complicated question. The answer is sometimes.
And I thought it was both 64 and 60.
Yes. So a great reference if you want to know, kind of get an idea of the details. This, for those that didn't see, there's this very nice website, Felix Cloutier. If you just type Felix x86 and then a name of an instruction, it'll be the top hit on Google. No relation, but this is amazing documentation on the implementation details of individual assembly instructions. The question is it 64-bit or not? So push can be any one of these encodings depending upon the size and type of thing that is being pushed. So just to interpret this real quick, this is pushing a register or memory address that is 16 bits, so 2 bytes. In 64-bit mode, that is valid. Now, in 32-bit mode, pushing a 32-bit register or 32 bytes or 32 bits of memory is valid. In 64-bit mode, which is what we're going to be doing in this course, that is not valid. You cannot just push 4 bytes directly to the stack.
What does E mean?
What does
Any?
I'm going to go, I'm sure there's a code on here, not equivalent, not equal, I don't know. It's a bad thing.
Okay.
All right. So it's a fair question. Somewhere on here they do have, on the page, there's an encoding table here. One thing that is interesting, which is what I just did here, I pushed a literal. I pushed 0x61. How many bytes is that? 1. It turns out 2 hexadecimal characters can count any value from 0 to 255. That is what can be represented as a single byte. So 2 hexadecimal characters is 1 byte. Very useful information to have. So I'm pushing a immediate 8. It is a literal number that is 8 bits and or 1 byte. That is valid in 64-bit mode, and it will be 6A followed by the immediate value. We take a quick look over here at my Python. What did we see that this was encoded to? 6A, and then the immediate value that I pushed. Now, you don't have to go here and parse all of these tables, and I linked another reference that is this like infinitely long table of every encoding of everything. You're welcome to stare at these tables. They are useful when you have a question about what is valid or not. I would encourage experimentation over reading documentation in this case. It's much easier when I have something set up here that I can just change this. Well, what happens if this becomes pop EAX? Oh, pop EAX is invalid, right? I said I couldn't push a 32-bit. Maybe I could pop one. No, it turns out I can't, right? Pwn tools blew up here. And what we see, this is a message from those same tools that you'd be calling. The assembler yelled at us and said, this is a mismatched type for a pop instruction. To me, it's a lot easier to try stuff and see if it explodes, as long as I can make small changes, run it, and take a look and see the effect. Now, one of the interesting things, which I'm not going to go into great detail on, is what am I popping here? How many bytes are being popped off the stack? Well, I'm popping into RAX. How many bytes is RAX? It's 8 bytes. Well, that's a 64-bit instruction. Does this have a 4.8 in it?
No.
It's kind of nifty. So the general pattern is instructions will be prefixed with that H. Not all instructions follow that semantic or that rule. There are instructions that are extremely common. Pushing and popping to the stack, for instance, is something that happens all the time. In Intel's Infinite Wisdom here, although I think it was designed by AMD. But in the designer of the instruction set, Infinite Wisdom, things that happen a lot tend to be shorter in length. Was that a question or no? Okay, cool. So why else should you use Python? Well, I said, this byte string. I can interact with this programmatically. I can sanity check I can sanity check myself and not worry about, did I spot it correctly? So now I have this check. Is there this H? Oh, it's bad, bad, bad. Now I know I need to fix it. And you can iterate on this as somebody who has studied computer science to make the language become the tool for you. And that is strongly my suggestion. Not that you have to literally write what I wrote, but whatever makes sense to you for programmatic logic to problem solve, use it. We're programmers, write programs. Okay, so that is one thing. And I go into more detail about some of the options and things you can do here in that 40-minute video. I'm just going to touch on highlights.
And pop, I'm just making sure pop takes out 4 bytes, right, of the stack?
So pop will take off of the stack the number of bytes that the register specified receives. So here I'm specifying pop RAX. RAX is an 8-byte register that is going to pop 8 bytes because I'm going to fill that register.
Okay.
Now, I said that you can't push and pop 32-bit. I cannot push and pop 4 bytes at a time. If I go and check out Felix's great documentation here, what we do see is that you can push 16 bits in the 64-bit mode. That is valid. So I can push 2 bytes at a time, or I can push 8 bytes at a time. Don't ask me why. Those are the rules. Okay. So one of the things that was asked was, how do I debug my assembly in GDB and get an idea of what's going on in memory here? Now, you could, and this would be a totally reasonable thing to kind of initially do, and it's totally valid. And I show how to do this in the 40-minute video. Pass your shellcode into the challenge binary, debug the challenge binary. You can do that. But if we're just exploring and reasoning about the actions of our shellcode, and we don't really care about being inside of the challenge, we're just trying to make sure that we're doing what we think we want to do, we can say GDB debug assembly. I have that exact same thing. It's probably going to yell at me. But what just happened here? Boom. We dropped into a GDB session that starts right at my shellcode. Now, this happened to pop up because I'm in tmux. Tmux is amazing. You don't have to use it. If you want to use this same type of functionality and not be in the terminal, you can use the Dojo's desktop interface, and that floating window that is your terminal, it'll pop up a second one with GDB. Question?
What did you just type in?
One of the great things about this class is that we do stream and record things. This does say gdb.debug_assembly. I am going to try and move and cover as much helpful information as I can. I understand that I may be moving at a rapid pace. The idea is I would rather throw information at you that you can review than spend a lot of time repeating information that I've already stated, although technically this is included in that video. So this is something that was useful. Now, the other thing that you may want to do is pass. I'm going to make my shellcode still be, my shellcode is that ASM thing. Oh, what if I want to get that shellcode into a process? I want to get it into the challenge, right? And you're like, oh, I got to cat it. I got to be on the terminal, right? I got to do it that way. No, it turns out this problem is solved here in Python as well, right? Smarter minds have prevailed. And we can say P equals process challenge. I have to cheat myself here. Okay, what do I have? Oh, A.out, because I'm using my test binary here. What this is going to do is start up that challenge. I can now programmatically interact with standard in and standard out. To give you an idea of what that means, I can say P interactive. Okay, I got my programmatic output here of my analysis, which is fine. And it says I'm switching to interactive mode. If we take a quick look at the code that I had here, what you see is we call read. Right now, this is waiting for input. The program is blocked on read. If I type in some nonsense, we get EOF. We say, and we mash enter again. We see we got that same illegal instruction that I started this demo with. I'm doing the exact same things if I ran it on the terminal, but now we are doing this programmatically. So I can, again, rapidly iterate. But I don't want to type A, B, B, whatever. I don't want to type the shellcode bytes into this thing. I want it to just go in there from the get-go. P.send my shellcode. I am now generating the shellcode, building it by just mashing enter, sending it into the challenge, running it, and we see the challenge ends. We happen to segfault. It's actually perfectly reasonable to segfault. Think about what your shellcode does here, right? If we start executing here at move EAX, after that instruction's ran, what happens to the instruction pointer? It marches forward, right? It just goes to the next instruction. Well, what happens when I reach pop RAX? What does the instruction pointer do? Same thing. It just marches to the next location in memory, right? I didn't write shellcode that happily cleans up. Right? I didn't call exit. I didn't do anything. So the instruction pointer is just going to mindlessly go to whatever is next in memory and be like, hey, man, we're going to try and execute this. Odds are quite high it will not be a valid instruction. That's totally fine. If I'm a hacker and I'm just trying to execute some assembly instructions to accomplish my goal, do I care if this program exits cleanly? No. Did it get me the flag and then die? Great, it did its job.
So are you saying it can give you the flag then set fault?
Yes, so hypothetically here, imagine that I had shellcode here that looked something like, spoiler, this isn't as useful as you think it is. Don't rely on it.
If it works, don't use it.
Okay, I have to print. This is more Pwn Tools magic. Pwn Tools also has a giant library of like common shellcoding things you may want to do. I'm typing shellcraft, cat 2 flag. There is a cat without the 2. There are different ways of doing exactly what we started off saying. Open, read, write. Okay, that is what shellcode is that would do that. Imagine I had this shellcode running inside that target binary. It's going to call open, it's going to open the flag, it's going to read the flag onto the stack, it's going to call write, it's going to write it to standard out, and that is what happens right here. Then the instruction pointer continues and it seg faults. What happened before it blew up? It gave me the flag. It put it to the screen. Now, calling open, read, write is not the optimal path. There was a great meme that mentioned something called chmod. I would recommend you check that out if you're not familiar.
In chmod will replace read, write, and
So you could write this yourself. All right, that is shellcode that will ultimately call chmod on flag with these permissions. The O, the 0, lowercase o, numerically that means I'm representing an octal number, very similar to how when we talk about hexadecimal numbers, I'm starting with 0x. It turns out chmod uses octal numbers, and that's why I'm using that. 777 is I want everything to be open, read, write for the owner, open, read, write for the group, open, read, write for everyone else. Whatever, if this were to run successfully as root, it would make it so anyone could cat the flag. It's kind of similar to what our bug was here on the infrastructure. There's change owner instead of change modifications. Yes?
If we run this, will it work?
If you run this, will it work? So let's consider the very first challenge. All right. What are the requirements on the very first challenge?
Literally just get shellcode, they'll give you a flag.
That is not true.
We're talking about level 4.
You will stop on the first line.
Shellcoding flag, but your input data is filtered before execution.
Okay, and what is this filter?
No idea.
That's not a good sign if you're in this class. The filter, it says no H bytes. Or you said earlier H bytes were hex 48. I just took what Shellcraft gave me and I said, all right, cool, let's take a look at it. Let's apply that same thing I just showed you earlier. Let's print it out. How many H bytes do I have? There's one here, there's one here, there's one here, there's one here. If you were to just take that and ram that into shellcode level 4, which is the first challenge assigned to this course, this would not work. However, this can give you inspiration or a starting point. You can use whatever you'd like, and when it doesn't work, I will laugh. One thing that you'll notice here is these instructions up here, this looks like a little bit of weird nonsense going on. It's very common when you're writing shellcode to want to obscure what you're doing. So if we were to take a look at what is happening here, we are moving 1010, I think it's 01 actually, but repeated ones into a register. We're pushing that to the stack. We are moving some constant. I'm going to give it away here. This right here is /flag. All right, it's in reverse because it's a number. We have to think about how endianness applies here. We're then going to XOR the value on the stack with that constant. This is a way of obscuring the value /flag and then revealing it in memory. Because hypothetically, there could be a program that is stopping you from passing in these characters. And so the default kind of assumption here of shellcraft is, hey, let's try and be a little bit sneaky, but it doesn't have a, hey, don't give me H bytes. So useful to a degree. Yes?
In a scenario where I have a program where you can't necessarily use the word like flag, then you
In the challenges, I don't believe so. At least not in what's assigned to you right now.
but then you wouldn't even be able to use like a symlink to make it point to something else, because then you would still need to reference flag.
So you bring up something interesting, and I'm going to continue it off of where I am right here. So it's doing a bunch of nonsense here that doesn't apply to you. Could I just remove that? Yeah, I could use the draw from this for inspiration and be like, I don't care about XORing stuff. Let's not have it. Let's do something simpler to get flag on the stack. Now you mentioned, hey, there's symlinks, right? As far as the like common strategies, tips, and tricks that you can employ to make your life easier, how many bytes is /flag?
5.
Okay, so it is 5. Interesting fun factoid, depending upon what exactly you're doing with it. This is a C string, so you do need to have a terminating null byte. In a lot of cases, you may end up with that by default, but I would argue 6. Because if that byte after the G is not a null byte, it will not be parsed as flag. So that's 6 bytes that I have to include in my shellcode in some way to get in there. Well, what if instead I draw inspiration from the great mistake of the evening? I'm going to type ln-s. This is hidden for Twitch because I know my face is over it. ln-s/flag A. This is going to create a symbolic link to the flag file, and it's going to be named A. How does that help me? Now I don't have to have those 6 bytes. I only have to have 1 byte.
And that byte is A.
That byte, well, technically 2, because I have to have the terminating null byte. That's on me. But we could reference the flag file now with just A. If you're not familiar with how symlinks work, because I saw a reaction there. Let me see what I got. Okay, so I'm over here on the left-hand side. I am going to echo hello world into my file. And if I cat my file, what we see is hello world. All right, that's not a surprise. Now I'm going to do that same thing, ln-s. The syntax here, -s is for symbolic. Anytime you're creating a link, 9 times out of 10, what you want is symbolic, so just trust it. I'm going to point this to my file. That is the destination that I want my symbolic link to point to. I'm going to name my symbolic link B, because A is already taken. What do you think will happen if I cat B? Yes?
Hello world.
It's going to say hello world. And that is, in fact, what we get. Symbolic links, we can think of them, and they're shown as, if we were to run lsl-l on a symbolic link, what we see in the representation is this is the name, and it points to my file.
What would be the hex you would reference for that in for assembly code?
So the question is, what is the hex I would include in my assembly code if I wanted to reference this symbolic link? Well, if we understand how paths work, for instance, relative paths and absolute paths, right? When I did /flag, I was specifying an absolute path with /flag. In this case, my symbolic link is in my working directory, right? It's in the same directory that I'm running my code. So I could reference that, and we'll do that just in Python. I'm going to say with open B, I want to read it as F, and I'm going to print F read. The path to access that symbolic link, since it's in my working directory, my current working directory, is literally just B. I can open B, and what's happening is I'm actually flowing through and opening the file that I'm pointing to, and so I get access to that content. Yes?
Are like symlinks used like for malicious purposes?
So the question is, are symlinks used for malicious purposes? The answer is they certainly can be. We will abuse symlinks to a large degree, not only in this module as a way of having a shorter path, right, which is great when you're trying to write shorter and shorter shellcode. Let's not have 6 bytes of my 6-byte shellcode be flag, right? To give you a clue on what the last challenge is. But we can also abuse symlinks in other contexts. And so symlinks will be a tool that we will reoccurringly use to create scenarios that were not necessarily known by the program or intended by the program. Was there a hand over here? No. Yes, one in the back.
So the challenge folder are inside in the root folder, so we cannot make thing making our real challenges.
Could you repeat that? I apologize.
Okay, so when we're working on the real challenges, the challenge folder are inside the root folder, so making thing make.
Okay, so the question, if I understand it correctly, is hey, the thing that I want to actually access is at root. It's root flag, right? How does a symlink help me there, right?
I mean that making a thing inside the challenge folder giving me the permission.
Okay, so I am in home hacker examples right now. The flag is at /flag. I'm going to create a symlink, ln-s. I'm going to specify /flag, and I'm going to name this C. If we lsl on C, C is in my current working directory. When I access C, it is going to truly open up flag. Now, symlinks do not solve this permissions problem because the flag is owned by root. I have to be root to get to it. So the fact that I made, as the hacker user, a symlink to /flag, this does not help me, right? It doesn't let me suddenly read it, but it gives me a shorter name to refer to that file.
So it's in your assembly. I can reference the hex and the hex for C, and that will point to flag.
Correct. The statement for Twitch is, so after I've done this, why is this useful in my shellcode? Because when I am writing my shellcode, instead of trying to open up /flag, I can reference it as just the byte that is C. Now, if you want to know what is the byte for C, man pages are your friend. Any opportunity I have to tell someone to read a man page, I will. If we type man ASCII, this is going to show us an ASCII table. And this shows us the representation of every character in ASCII. And C, we're using a lowercase c, so I got to go down a little bit. I believe it's 4-3. Did I go too far?
It was up there.
Oh, 63. Okay. So hex 63 would be the numerical representation or the number that I want to push to be the character C. Now, you'll notice a theme here that I show you some giant table and then I say, hey, look, you don't have to. It's great to know it's there. There is a better way. pwn.tools is your friend. Consistent theme. All right. pwn.tools has a number of functions that refer to the concept of packing and unpacking. This is the conversion of like a representable human interpretation of the bytes to a numerical representation. A lot of the time you want to deal with numerical representations. There is a P64, that is if I want to pack 64 bits or 8 bytes. There is a P32 that's going to give me 4 bytes. There is a P16. Any takers on how many bytes that's going to pack? 2. There is also a P8. I'm going to use P8. There's also a generic pack. All right, I could run through amazing functions all day long, but I don't think that's what you're here for. If I pack 061, I get the character A. If I pack hex 63, I get the character C. Similarly, there is a U8, which is going to do the inverse operation. Now, why does it show 99? Right, it's base 10. That's a decimal interpretation. What if I want to see what this is in hex? Python is your friend. We call hex on the decimal number. It's going to display the hexadecimal. So we went one way, we went back. This is a very useful way of programmatically specifying that I want to include something and make it obvious when I'm looking at my script what I'm doing. Who here knows what an F string is? All right, we got a few. An F string in Python is a string where you can substitute variables. It turns out the secret to making an F string is you, as the name kind of implies, start the string with an F. What does this let me do? Now I can define variables in this string. For instance, maybe I want to, what do I want to do? Let's unpack. So I'm going to U8 the character C inside here. I'm running out of time, so I'm going to spoil another thing here. Just like how I had GDB debug assembly, where I was running the assembly in isolation, I can use GDB debug on a binary and still programmatically send that shellcode in. One of the tricks that I mentioned is you can throw an int3 at the beginning of your shellcode. Int3 will result in a sig trap signal. If you are inside of a debugger and int3 is executed, a sig trap will occur. GDB will catch it and treat it as a breakpoint. Right now, I am not at my breakpoint. When I use pwn tools to perform this action, it is going to, by default, start at _start. This is like the beginning of everything in the life cycle of this binary. I don't care about this for what we're doing today, so I'm just going to continue through. You'll notice that I did not set, there's no breakpoints. I didn't set anything. All I did is I threw that int3 in there. And I mistyped something. Yes, it is very important that you define P if you're going to interact with it. So I use P equals GDB debug. It's the same syntax as if I were saying P equals process. I'm just saying now I want to start it up and simultaneously debug it. So now we're at that start. I hit C. Where did I end up? You can't see it, but I'm actually right above, or right after that int3 instruction. I immediately, very quickly, got to my shellcode. This isn't my shellcode running in isolation. This is my shellcode inside the challenge binary. We see up here, this is home hacker examples a.out. I am running the challenge, or not the challenge binary, but my example binary and stepping through the shellcode that is running inside of it. With that, I've got a couple minutes, and I kind of lied. I said the first thing I was going to explain is the magic of my GDB session. So sometimes, we get a little off the rails. Yeah, you have to redirect me if we get there, but hopefully it's been good stuff. So how do we deal with Jeff and get the pretty looking GDB interface? Well, it turns out if you create a file named GDB init, note the dot is important. And we create this file in our home directory in /home/hacker. We could also get the squiggly tilde. They mean the same thing. You're going to see mine. Now, I have a lot of things in here. The thing that is immediately relevant to why does my stuff look pretty is this line right here that says source opt or /opt/jeff/jeff.py. The other lines, this first one I'd highly recommend. If you're unaware, there's two versions of syntax. We're looking at x86-64. There is only one correct syntax, and is the only syntax we will use in this course, and that is going to be the Intel syntax. By specifying this line here at the top in my .gdb init, GDB will show me Intel syntax, and I never have to look at that ugly thing they refer to as AT&T syntax. These other things you're welcome to copy, but if you don't know what they do, I'd recommend you don't. If I comment that out, you'll see I have to be in my example directory, GDB a.out. I run, okay, now I don't get any of this pretty. And if this is what you've been working in, that I feel you, I can do it, but it's a lot nicer to have a plugin that is going to just show me a bunch of stuff I'm interested in already. There was a hand over here.
Yeah, so you commented that phone DGB.
Okay.
Over that?
My personal preference and the kind of preference of the general pwn college instructors, we've agreed to kind of standardize on Jeff. That way it is consistent across courses, and you can use the same tool across these classes where we kind of rely on this tooling. If you want to use pwn debug, that's perfectly fine. Much like if you ask me how to use VS Code and I go, I don't even know how to open a terminal or edit a file. If you ask me how to do something in pwn debug, you're very likely going to get a very similar response. There may be an instance later in this course where I switch to pwn debug for technical reasons as far as different functionality that is offered. But whenever possible, I will be using Jeff. You're welcome to use whatever you like. Question?
In class after one time, could you just keep the your GDB init on the screen?
All right, so the question was, can I just keep the GDB init on the screen? With that, I am out of time. I'll leave this up here. You are welcome to ask me questions as long as nobody kicks me out. I'm sorry, Twitch, if you are watching and had questions. The Twitch app on my phone just doesn't like your chat. I will try and fix that next time. And wait.